Change the force, keep the mass same. Change the mass, keep the force same. It sounds confusing at first, but once you understand the practical, it usually becomes very simple. The aim of this practical is to investigate how mass and force affect acceleration. And there is a formula written on Newton's second law: force equals mass times acceleration, okay? Or F equals m times a. In this practical, you can be asked questions in two different ways. The first way is that they can ask you to change the force and measure the acceleration. So if you change the force, this becomes your independent variable. The acceleration is what you measure. So this becomes your dependent variable, as you already know. Please remember that this very important point, that the mass has to remain constant. What did I say? The mass has to remain constant because you are changing one variable and measuring the other. To keep the mass constant, you set up the trolley like this, and you have a light gate, and this light gate is connected to the data logger of a computer. The data logger will give you the acceleration. It can calculate the acceleration automatically, and you can simply read the acceleration from the computer. The trolley has this small piece of card attached to it. You can look at this later at exactly how this piece of card helped the data logger work out the acceleration. But let me explain the basic concept first. The most important thing that many students do not understand, that Earth is pulling the hanging masses downwards. This pull is a force. The force pulling this mass down due to the earth is called weight. The weight is the force. You can work out force using the formula weight equals mass times gravitational field strength. The gravitational field strength is approximately 9.8 Newton per kilogram, and the mass will usually be given to you in the question. You can use these values together to calculate the force afterwards. You then calculate or measure the acceleration using the data logger. Now, one very important thing is understanding how you keep the mass constant. You keep the mass of the entire system the same. You can see in this picture at the bottom that there are 4 masses hanging here. These masses provide weight or force pulling downwards. However, if you want to keep the total mass the same while changing the force, you will have to remove one mass from the hanging masses and place it on the top of the trolley. This means that the total mass of the entire system remains the same. You are not removing the mass and taking it somewhere else. You are just simply transferring the mass from one at a time from the hook onto the trolley. This is how you keep the mass constant. The second way this practical can be asked is that instead of changing the weight, they ask you to change the mass. They might be asked you to change the mass and then measure the acceleration. So the mass changes and the acceleration is measured again. Your variable now shifted. In this case, you keep the force exactly the same. You can change the mass by adding masses one by one onto the trolley and observe how the acceleration changes using data logger. However, to keep the force same, make sure that you do not add or remove anything from the hanging mass. This is because the hanging masses provide the weight that is pulled downwards by the earth. Therefore, in this investigation, hanging masses remain the same. That becomes your control variable, which is the hanging masses, which is contributing to the weight. So you simply keep that constant. This is the main area where students have the biggest gap in their understanding. If you understand it in this way, the rest of the practical becomes much easier. The remaining parts involve looking at the data collected from the data logger. You can make another you can use this sheet, which is, or download this sheet from the link below, and do all other read the method and calculation from there. Thank you very much. I hope this makes sense. Thank you.